This tutorial will show how easy it is to perform a nonlinear sequential construction analysis with ETABS. We start with a 4-story, 3-bay building. We will remove one of the first floor columns in order to create a transfer girder. This girder will be susceptible to sequential construction because it carries gravity loads from the upper floors. Next, we define the static load cases. For this example, we will use only the self-weight dead load case. Next comes the key step of defining the sequential construction case. The case will be called dead SQ, and if we were doing design, we could substitute this case for the static dead load. We could also specify geometric nonlinearities if so desired, and the load pattern will be the dead load case. The program has the ability to automatically create the active structure for which the user can specify the number of stories in each sequence. Or the user may specify the active structure, which is what we will use, where the user can explicitly define the stories in each stage. In this case, each stage adds an additional story. Lastly, we wish for the loads to be applied only to the added elements. This is to keep the lower stage elements from being loaded multiple times with the same load cases. Now that the sequential construction case is defined, we are ready to run the linear static analysis. The next step is to run the nonlinear analysis for the construction sequencing. We will change the 3D view to an elevation view with the dead load case displayed. In the right window, we will display the deformed shape from the sequential loading to see the effect that this loading approach has on the building. We set the scale factor to 200 to match that on the left. Starting with step 0, the first floor undeformed, we can toggle up the construction stages. Note how the displacement at the transfer girder location grows significantly larger than that of the model where no sequential behavior is accounted for. In fact, a right-click on the girder shows the displacement to be approximately 1/4 inch for the non-sequential case, while the displacement is more than double when sequential effects are included. Next, change the left window to show the moment diagrams for the dead load case. In the right window, we will again show the results for the sequential construction case. Again, we set the scale factor to match the left window. Once again, the moment diagram for the transfer girder is significantly larger in the sequential loading case than for the case where the entire model acts together. This concludes this tutorial.